Hi, thank you so much for joining me. This will be hopefully a short little video clip discussing the properties of ionic compounds. I'm very big on a theme that pervades chemistry, and that's that structure determines function. So in previous videos, I talked about broadly the structure of ionic compounds, not in terms of crystal lattice. I don't cover that typically, but at least in terms of ion-ion attraction, Coulombic forces of attraction, the electrostatic attraction between opposite charges. So let's see how those types of structures impact their properties. Very high melting points and boiling points. Most ionic compounds are solids at room temperature. And that's because it takes energy to break. And if you have a strong ionic bond, and that's what we're breaking here, we're breaking very strong ion-ion attractions, that takes a significant amount of energy, and therefore they're going to have very high melting points. The other thing is that they're brittle. So if you take a rock salt that you might use for making ice cream, took a hammer to it, it's going to crush very quickly. You can use a mortar and pestle to crush salts. And that's because if I can give you something of an image of this. So an ionic compound is alternating positive and negative charges. Now, if I add stress, so if somehow I stress this, one of these layers is going to, let me do this in another color, one of these layers is going to shift. And what I will end up with is I'll still have my negative, positive, negative, positive, negative, but now because of the stress, I'll have a positive, a negative, a positive, a negative, and a positive. So do you see how I shifted that upper layer? That's what cleaving it and making it brittle, you're shifting layers on top of one another. Well, when you do that for ionic compounds, like charges repel. And so those like charges will repel one another and push one another away, and it will break the ionic lattice. So that's caused by ion-ion repulsion. Okay? Now, many, but not all, are soluble in water. Water is let me clean off this bottom here a little bit. Water is a polar substance. And so I have a partial negative on the oxygen and partial positives on the hydrogen. So if I had, for example, a sodium ion, a positive sodium ion, the water is going to gather around with the oxygens, right? Because partial negatives attracted to positive. And so I would get waters surrounding the sodium ion. And if I had chloride, then I would get the hydrogen end attracted because the hydrogen's partially positive. Now, many, but not all, are soluble. Now, whether or not they're soluble is a large conversation about energetics that I'm not getting into in this video. I will in another one, but not right now. So at this stage, I think it's important to know that if they are soluble, it is due to this attraction between the cation and the negative portion of the dipole of water and the anion and the partially positive on the dipole. So these are non-conductive as solids. To conduct electricity, we need movement of electrons. And to have electron motion, I need mobile ions. And so ionic solids are in that rigid alternating charge lattice They're not mobile as solids. And if I don't have mobile ions, I don't have movement. I don't have a pathway for electron movement. They are conductive in their liquid and aqueous, dissolved in water states. And the reason for that is if you melt them, the ions become mobile. If you put them in water, the ions are even more mobile. And if I have mobile ions, those mobile ions provide that pathway for the movement of electrons. So I hope you enjoyed this little introduction to the properties of ionic compounds, and join me again soon.